It's a huge pleasure to introduce Will Arnold. Will is the head of climate action at the Institution of Structural Engineers. You've already seen his face on the screen this morning in that film that he was very much responsible for producing. It was Will, back in July 2019, who addressed a meeting of the council of the institution when I was there at the time, and it was like scales falling from our eyes. Most of us in that room had no idea the extent to which structural engineering and civil engineering construction was responsible for the problems that we're seeing leading to the climate change and the CO2 problem we all know about. It was a complete revelation to me and to many others, and you will all know now the declarations that many of us have signed up to. Structural engineers declare, architects declare, civil engineers declare, construction declares a world emergency, which we're here to talk about. So without further ado, Will, I'd love to introduce you. Come and speak to us on your theme, please.
Thank you, Ian. Thank you for having me. I grew up in Macclesfield, which is, I mean, you were never going to host the symposium in Macclesfield, but this is about as close as we get, so it's nice to be asked to effectively come home to the rain that I grew up knowing and loving to speak to you all today. So I worked at IABSE as a building designer for just over 10 years before moving into my current role. I've been at the institution now for a little over 4 years, working in the field of sustainability and structural engineering. And the other thing that happened about 5 years ago, as well as giving that presentation to council that Ian mentioned, was that in this country, in the UK, we amended the Climate Change Act. We amended it to say that by 2050, this country would reach net zero. And since that happened, other countries have followed suit, and most countries around the world now, at least most major economies, have declared something similar. Net zero emissions by 2050. That was 5 years ago, which is actually quite a long time when you think about it. But if you go onto a construction site today, you might be forgiven for thinking that no such declaration has taken place at all. Bridges rise out of the ground in the same way they always did. Buildings being built today look the same as they did 5 years ago, more or less. We talk a bit about reuse, we talk a bit about embodied carbon. I would hazard a guess that not many of you are talking about the wider environmental impacts of where the sand comes from in your concrete or the water that we use and so on. We don't tackle this bigger picture. And I would argue that we're not really making the progress we need to make. So what I want to take you through for the next 25 minutes is a reminder of the impacts, the scale of impact that we have, a proposal for what we can start to do about this now to tackle this broader picture than just carbon. And then I want to pose a question at the end as to questioning whether or not net zero and net zero carbon is even the right thing to be aiming for in the first place, because perhaps that's why we're not really making the progress that we need to see. So let's start by looking at impact. I want to start by talking about the lifespan, life cycle of a material, a construction material or any material for that matter. It kind of goes through these 3 steps. We take something out of the ground, we dig it up and we pluck it out of the ground. We turn it into something useful that somebody decided that they wanted at some point. On the way here, I decided I wanted a flat white. So, we turned some materials into this. We use it and then we throw it away, right? We discard it for the most part. And I'm not talking about 10-gram cups made out of paper. I'm talking about 10,000 tons of concrete and steel at a time. We throw them away. In terms of the impacts, in terms of the scale, the order of magnitude of all of this, 50%, half of all materials extracted around the world every year go into construction. They are construction materials. 1/6, 15%, 15% of all carbon emissions are due to the production of construction materials for buildings and infrastructure. Most of that is steel and concrete. And then the waste that we create, the stuff we throw away at the end, well, about 1/3 of the world's waste comes from construction materials. So it's absolutely phenomenal, the impact that our industry has on this world. And there's not very many of us, which means the impact per person is relatively high compared to the impact per person of a dentist going through disposable gloves and things like that. We extract and use so much stuff on this planet that in 2020, the weight of all human-made stuff surpassed the weight of all naturally occurring biomass around the world. There's more than 1 trillion tons of stuff that's been made by humanity now. And that's more than the 1 trillion tons of living things that exist. And we add about 10% to that figure every year. So this was 2020. And I've not seen the updated numbers, but we extract about another 100 million tons of material per year. And every time we do that, every time we extract and we add to the bottom of this diagram, we have a negative impact on the living stuff on the top of the diagram. So as we dredge gravel from rivers, we impact the stuff that used to live there and probably doesn't anymore. As we process these materials into construction materials, as we come to think of them, as we heat them up and we bake them and we change them chemically, we release greenhouse gases, we release pollution and so on. And then when we leave this waste behind at the end of life, that has knock-on impacts as well. The bit out of all of this that we are talking about, thank God, is carbon emissions. How do we get to net zero? How do we reduce carbon emissions? How do we decarbonize our materials and the way we use our materials? This is the one topic we are talking about. And there's been quite a change in the last 5 years in the construction industry, at least in the countries that I work in, where people have started to put this front and centre, which is very much needed. But let's see how well we're doing. We'll just do a little marking session. We'll see if we can mark ourselves out of 10. So as I mentioned, most of the emissions that come from construction materials come from steel and concrete. It's about 2/3 of all construction material emissions are either steel or concrete. The UN refers to these materials as hard to abate emissions, by which they mean it's bloody complicated to get rid of them. And it's basically because we need a huge amount of energy, because we have to melt and bake things at about the same temperature as the flames at the bottom of a Saturn V rocket. And these flames run all day, every day, throughout years and decades. And then we change the chemical composition of these materials, and in doing so, we release carbon dioxide as a chemical reaction. It's unavoidable. So these are really difficult things to deal with. To be very clear, there's no silver bullets with this. So if any of you are sat there thinking, oh yeah, but it's okay because there's a thing called GGBS and we can use that instead of cement, and there's a thing called scrap steel and we can just recycle that, you cannot. Both of those materials are constrained and fully utilised globally. If you ask for more of it, somebody else will get less of it. Global emissions stay the same. There is no simple answers to this. So instead, what our materials industries are proposing is novel ways of making cement, novel ways of making steel, primary steel from scratch this is. Both industries are relying on hydrogen. Both industries rely on carbon capture. So the good news is we've got a plan, right? We know that if we do these things in order, we can demonstrably make these materials with near zero emissions. And the good news is that the industries are telling us we can do this by 2050, which is, of course, a very long time away, although not as long as you think. When you add up the numbers, it's about 26 years from now. I'll still be working. A lot of you will still be working. Probably almost all of you will still be alive, so it's not that far away. But we will get there, right? The materials industry say we will get there by 2050, so that's good news, right? Unfortunately, it misses quite a big piece of the puzzle, because what we care about is not the emissions being released in the year 2050. What we care about is the sum total of all emissions between now and then. So this graph, and apologies because it is a bit washed out, but you can probably just about make out two light blue greyish lines towards the top that curve down in a nice convex shape. Those are the steel and concrete industry's projections of how quickly they will decarbonise. And I've deliberately made them both the same colour because I don't care which one's going faster than the other. The point is the general trend. It's a convex curve. It bulges outwards. The black line is what the IPCC tell us we need to do in terms of emissions if we're to stay within 1.5 degrees, which most of you kind of already know on a global scale is kind of gone out the door. But even to say within 2 degrees, you get a concave line. And the area under the graph of that black curve is much smaller than the area under the graph of the grey and the blue curves. That means that regardless of whether or not we get to 2050 at zero emissions, the amount of carbon released into the atmosphere between now and then is far, far greater than what we are allowed to emit. It's really simple. So the elephant in the room with all this decarbonisation, all this net zero 2050 talk is, yes, we have a way of technically producing steel with no emissions. We think we have ways of making concrete from cements that are produced with no emissions, but we won't get there in time, and it's far, far too slow. So the one area of all of that environmental damage I talked about that we are discussing, we are considering, unfortunately, we're going far too slow on. Marks out of 10, we might scrape a 2 or a 3, I would suggest. Room for improvement. Now, if that's the elephant in the room, then it's a pretty bad metaphor, but I was trying to think of what would be even worse than an elephant in the room, and I came up with a whale in a fishbowl. I think the whale in the fishbowl here is all that other environmental damage that we're not talking about whatsoever, because we have no idea what the graph for that looks like. We have no idea what our impacts on nature look like for that. And it's interesting because the UN speak about carbon and biodiversity loss and pollution in the same sentences. They talk about a triple planetary emergency. The Sustainable Development Goals tackle all of this together because they're all interrelated. So we probably need to start doing the same thing. The facts are really simple. You can produce the lowest carbon concrete in the world and pat yourself on the back for the carbon emissions bit, but if you want to pour 100 cubic meters of it, you still need 120 tons of gravel. You still need 60 tons of sand, 60 tons of limestone, and 17,000 litres of fresh water. All of that stuff comes at an environmental cost. There's pollution, there's land use change, there's habitat disruption, and so on. And we talk about biodiversity net gain on our sites. We talk about planting hedges and trees and stuff around the things that we create on our sites. But we don't talk at all about the equivalent impacts where our materials come from. And this is important because actually I think this is where most of the problem lies. Now, if we look at carbon for a second, and we talk about, you have to excuse me for those of you working bridges, but if we talk about buildings and carbon, we know that just under half of the emissions of a new building are the so-called embodied carbon emissions. This is greenhouse gases being emitted through the use of materials. The rest of it is the operational emissions, lights, electricity, air conditioning, and so on. If we plot a similar graph for biodiversity impacts on nature and so on, and we look at materials versus the other stuff, the numbers are a bit worse, they're a bit more shocking. We find, and the research in this area is quite nascent, so there's a bit of a range on this, but we find that the vast majority of impacts on nature, impacts on ecology, come from our use of materials. They do not come from what happens on our building sites. So you can plant all the trees you want at either end of your bridge. It's effectively irrelevant because the impacts we have on nature, where all that concrete comes from in the first place that we use to make the bridge, that's where the impact's being had. So we need to radically change how we start to talk about our materials if we're actually going to do something about this. So to summarise the problem, the impact as a whole is enormous. We know that, we've been talking about that for long enough, but hopefully you see now this is more than just carbon. The bit we are talking about, the carbon bit, we're not going fast enough, and the rest of it we're not talking about at all. So with that, I want to try and propose some solutions to you. I'm going to try and give you some things that you can go away and start to do as we move forwards. And the good news is I'm not going to propose any new metrics. You don't need to do any new form of counting. We don't need to use any new units. There's a really nice qualitative approach to all of this. And it follows 3 words. Use less stuff. It sounds pretty simple. Use less stuff. But it tackles all of this at once, right? Because if you use less material, you have less extraction, less pollution, less greenhouse gas, less waste, and therefore less impact on ecology. You don't have to do the maths to know that it's better. This is a diagram we use at the iStruct. We've been using this for a while now. We kind of first drew this to talk about carbon, but have since come to realise this covers all negative impacts, effectively. And what this diagram shows, stuff at the top of the diagram has the biggest effect on reducing those negative impacts. The stuff at the bottom is kind of like turning off the tap when you brush your teeth. You should do it anyway. It's a good thing to do. Of course you should do it anyway, but it's not going to save the planet by itself. Minimising waste, trying to change your material specifications, chasing those funky concrete technologies that won't be here for another 26 years, that stuff's at the bottom. The stuff at the top with the impact, that's building nothing, building less. It's a reuse focus. After that, we have Build Clever. That's about structurally efficient concepts, avoiding the silly gymnastics, avoiding the big wavy architectural moves that some in our profession have become quite well known for. Say no more. And there you can put percentages to all of this if you want to. The stuff at the top right-hand corner of this is going to save 100% of your materials because you're not building anything new. The stuff in the middle on the right-hand side, Build Clever, what's that going to be? 30%, 40%? So massive difference in the top and the middle. Bottom of this, talk about minimising a bit of waste on site. That's going to be, what, another 10%. So you can see where we need to focus our energies. And my challenge to you throughout this symposium, throughout these next 3 days, is to start asking yourself, with these examples I'm seeing, where in that hierarchy do they sit? Because it makes for a wonderful story and a fabulous presentation to talk about some shiny new technology that helps us do something more efficiently, particularly if it uses AI, modern methods of construction, and other acronyms that I forgot to write down before this presentation. We can get very excited and very carried away. But if all it enables you to do is a 15-20% reduction in material use, that's nowhere near good enough. Not even close. The stuff you need to be looking out for with your magnifying glass and your deerstalker hat is the stuff that said, because of some clever engineering and some good decision making, we managed to avoid building stuff. That's where your biggest impacts come from. And if we go back to that graph of material production, what we realize is, well, the gap between the decarbonisation projected for concrete and steel versus where we need to be, that gap by 2030 is pretty big. It's about 30%. What that means is, on average, across this industry, by the end of this decade, 6 years' time, we need to use 30% less stuff. 30% less stuff is Bill Clever, it's in the middle of that triangle. That means the average project, across all projects, needs to use less stuff. You lot, I'm expecting, will tell me we're better than average. We're market leaders. We are here as a centre of excellence to share knowledge about how we do these things the best we can. So you are not aiming for 30%. You lot need to be aiming at the top of that diagram. So it's build nothing and it's build less. And that tackles the carbon bit, but it also tackles all the other ecological impacts we don't yet fully understand. And that's the challenge going forwards. But that takes me on to the sort of third and final bit of this talk, which is to pose the question as to whether that's ever going to be good enough. Is it good enough to do less harm? If you spoke to a doctor and you asked them what their mantra every day they went to work was, and they told you that they just try and do less harm to their patients, how would you feel? Would you book an appointment with that doctor? Is it good enough to do less damage? Is it good enough to emit less greenhouse gases? Is it good enough to kill less fish, if you want to sort of boil it down to a really basic level? Is being less bad going to fix our problems? NASA tell us that if we stopped emitting greenhouse gases today, all of them just stopped somehow, including holding our breath, I imagine, then the levels of atmospheric carbon wouldn't return to pre-industrial levels for like at least 100 years, way beyond our lifetimes. This graph is a replica of the one on the NASA website. You can see how much more slowly it goes down than it's been going up. So if we just stop emitting, that's not going to get us to where we need to be by 2050, let alone 2100 and beyond. The same is true of what we're doing to nature. If we, at the moment, have got big open cast mines that are spewing out pollution in terms of noise and dust and chemicals going into the ground and so on, that's damaging all the stuff that lives in that environment, and it has a knock-on impact for tens of kilometres in every direction. If we just close the mine tomorrow, nature won't just recover overnight, it takes time. And whilst we're waiting for that recovery to happen, of course, we've damaged and lost something like 2/3 of all wildlife around the world, and we continue to damage it because of what's happening to the climate. So you've got these vulnerable pockets of nature that we could leave alone in the hope they recover. Meanwhile, we're getting worse and worse storms and flooding and fire and drought and so on. They don't have a very good chance. So doing less damage doesn't really seem like a viable goal to fixing all of this, does it? I like to use an analogy. The guy in our marketing team was a bit confused when I asked for a photo that looked like this for this talk. When you were younger, or maybe more recently for some of you, you might have been left with a free house for the weekend. Maybe your parents went away or your carers went away for the weekend. You had a free house and you thought, brilliant, I'm going to invite around all my mates. We're going to have a big party. We ordered beer and wine and pizza and spirits. And then you probably remember waking up the next morning with a bit of a blurry vision and a banging headache, and you looked around and you were surrounded by effectively a catastrophe in your parents' house. And then it dawns on you that your parents are due home in 3 hours' time. I don't suppose many of you suggested making less mess at that point in time, right? I don't know if any of you woke your friends up and went, quick, we need to order beer and pizza, but not as much as yesterday. 10% less pizza within 1 hour, 20% less within 2 hours. Right? It doesn't work, right? Wouldn't work. So instead of be less bad, you reverse things. You went into do more good. You said, we need to clean up the house. We need to do the opposite of what we were doing yesterday. You went from be less bad to do more good. And we need to apply that mentality to the construction industry. this is how we get gravel out of rivers. We just dig it out. We don't know what's living in it. And in most parts of the world, we don't do anything afterwards to replenish the fish stocks were there. How would it look if instead of doing less bad, which would effectively just mean using less gravel, we did more good? What would it mean if whenever we said we need gravel to make something, we got hold of that gravel in a way that the fish life thanked us for afterwards? Because life there flourished more than it was surviving before we were there. Now you start to get into reparation. Now you start to get into do more good. This is the way the construction industry has to go. And when we talk about regenerative design, this is what people mean. They mean about aiming to do more good. That's the general outcome of regenerative design, is do more good. We recently released a book about this at the institution called The Regenerative Structural Engineer. I'd highly recommend it. It's pocket size as a book. It's not a guide. It's not a Eurocode guide. It's a book. And in there, the authors define regenerative design as, oh my God, that's a different font to what I put in originally. So it's even bigger, so you can definitely see it. The goal of regenerative design is for human and living systems to survive, thrive, and co-evolve. This is different to what we talk about with net zero. It's different to how we talk about sustainability. This is not human stuff happening in isolation, as we do with, say, carbon. This is recognizing we're part of one system. And as nature disappears, it affects us because we lose food crops, we lose resilience in our forests, and therefore forest fires happen, and therefore we get into feedback loops and so on. So it recognizes that systemic thinking. And the goal is not to do less damage, but it's to help these systems that we're a part of to survive and thrive and co-evolve into the future. That's the goal. That's the definition of regenerative design. And in terms of how that applies to structural engineers, to all of you lot, this comes back to materials. If we go back to those earlier slides about extraction and use and waste, that's where our impact can be. And our impact can be huge. We know it can be huge because at the moment it's hugely damaging. So it could be hugely positive. So we could switch from creating less waste to using waste in our designs, drawing down on waste, not using anything unless it was either waste or completely renewable in a short time span. Instead of talking about reducing poverty, what if the goal was zero poverty and then the opposite was to get people as far away from that poverty line as we could through every bit of activity on our projects? Not just the fact that at the end of it we're left with a building and that's a good thing, but the construction methods behind it, the design methods behind that, the extraction methods behind the materials. To do this, we need to understand where our materials come from, who extracts them, who processes them, what systems around them are impacted by all of this, and then we need to understand what the current impacts are and what they could be. So there's a long way to go before we can do this in depth on our projects, but it doesn't stop us from starting. It doesn't stop us from tackling these sorts of aspects and trying to embed them in our work. And because you're probably sitting there thinking, that's great, Will, but that's very hypothetical and you're no longer a design engineer, so why should I trust you? I'm going to give you 3 examples of people doing this today to try and hammer it home that this is possible. There's 2 caveats to this. Number 1 is that these are all relatively small scale. And a lot of people say, oh yeah, but it works on a small scale. We'll never scale it up. Well, most inventions in the past and most new ways of thinking have started at a small scale. It's our job to work out how to scale these up, how to apply these in a commercial environment in the so-called developed world. Because if we can do it in the developing world, then by definition, if we're more developed, as we claim to be, we should definitely be able to get away with doing this stuff. Number 2, the second caveat, well, it's not a caveat, but it's a point to note. When we talk about design in this sense, it's a verb, not a noun. It's the act of designing. It's not that you end up with a piece of design that is regenerative. It's the act of doing this is regenerative. Because it's about asking these questions, it's about understanding this stuff, and it's about working in a way to create positive outcomes. So the first example, I'm very pleased to say, and I didn't even know that you were going to be the main charity for this event, so that's lucky, isn't it, is Bridges to Prosperity. And it's not because the end use of the bridges is phenomenally positive, because of course it is, and that's what you're well known for. The reason why I picked B2P is because the construction methods you employ, the design methods behind them, they create jobs, they draw down on waste because you reuse materials, they aim to be as positive as we can be. This is not about doing less harm with our work. This is about doing as much good as we can. I imagine that the base reason behind reusing bridge cables comes from cost as much as anything, but it does a hell of a lot of good things for the planet by not sending those things to landfill, which is where they may have ended up. By training people up on site on how to look after and maintain these bridges, yes, it might be cheaper, and again, maybe that was one of the benefits of doing it, but the real impact comes from the fact you can leave that bridge there and go away, and people will look after it into the future. Survive, thrive, and co-evolve. As the weather gets worse, and the flooding gets worse, and every now and then that bridge gets damaged, people who live there have co-evolved with it, they can deal with it, they can fix it. So you're working in a regenerative way. So this is bridge building with the sort of aim of wholly positive impacts. This is a office extension project in the middle of London. You wouldn't know it from looking at the outside of the building, but it's one of my favourite projects in all of London. Engineers on this were Hine Tillett Steel. This is a refurb with a vertical extension, so one new floor on top of the building, and that extension was built out of reclaimed steel sections. So at first look, at first glance, you might assume that this is me singing the praises for reclaimed steel and the use of reclaimed sections. It's not. What's regenerative about this was the fact that the engineers wanted to use this project to try and change the industry as best they could. They saw the systemic problems with extraction and use and waste generation, and they said, we've got an opportunity to do something different on this project that people are not doing, because people have not been reusing steel very well recently. They're doing it fine 100 years ago, but not recently. So they said, we're going to change things, and we're going to use this to create as much impact as we can. So they created tools for doing this, and they gave them away to the industry. They run training for other people. They go in and do lunch and learns. They've given away all their company secrets around reusing steel. They've written guidance with the SCI and so on, and it's helped the industry to move quickly in a direction towards being able to reuse steel frames. And the acceleration on this topic in London in the last 2 or 3 years has been phenomenal, helped by people like Hine Tillett Steel. So this is not a project, this is not an example of steel reuse, this is an example of construction in a way that changes the industry. And again, it's the verb, it's the act of design that does that. And then the final of the 3 examples is a project out in Rwanda, probably not too far from the bridge that I put up at the start, by Mass Design Group. And Mass have this sort of ethos of working where they want to wholly understand what an area needs, what a system needs before they start designing for it, which is something I don't think we're typically very good at on our projects. We usually take the brief and assume the brief knows everything and we get on with it. They don't work like that. They go in and they work out what's really needed. And so this project, this was the construction of 50-something new buildings. It's a new university. But what's regenerative about it is that the materials they use, the processes they use, the way they approach construction were all designed to increase jobs, increase training in things that didn't exist. They tried to make earth sexy again because there was a whole lot of earth buildings in Rwanda, and then the government decided that this was a poor person's material, and they nearly got as far as banning it. So this was used to put it back on the agenda. These were design decisions entirely driven by sort of local needs. And if you take those 3 examples, so you've got bridge building with this sort of aim of wholly positive impacts, you've got construction in a way that tries to change the system, and you've got design decisions understanding those broader needs, this is what we mean by regenerative design. These ways of approaching design gets us from less bad to more good. It gets us into a process of design that gives us some chance of helping people to survive, thrive, and co-evolve into the future. And it's that mentality that we need to start working out how to scale up onto our bigger projects. Yes, these are small. Yes, a lot of it's sort of charitable work. Your challenge now is how do we apply this to commercial situations with insurance and risk and liability and all of those sorts of horrible words that I hate. How do we question the brief? How do we bring the clients along for the ride? When do we speak to them about it, and so on? So my final 2 slides in summary for you. Impact to the industry is huge. You already know that, but the numbers just get worse every time we sort of dig a bit deeper, frankly. Use less stuff is a pretty good mantra. Hopefully will help you today with your work. But we need to recognise that that's an interim step, because that's do less harm, and we need to start doing more good. Which means that over the next 3 days, my challenge to you will be this. Be a critical friend to each other. If you can't quiz each other with difficult questions here, you definitely can't do it out there in the real world where your clients can hear you. So we need to do this here. And when you're being critical, try and ask 2 questions. For examples today, where does this sit on the hierarchy? How good could it have been higher? Is this a 10, 20% saving? Why is it not an 80, 90% saving? What would have to be different next time? And then, more fundamentally, when we talk about next steps, how could we go on a project like this from being less bad to more good? How can we take those examples of those projects that I just showed you and try and apply them in situations like this to try and get this way of thinking into the mainstream? Those are your two challenges. I look forward to hearing how everyone gets on over the next few days. Thank you very much.